Recording in progress.
Right. Welcome everyone to this Marches Full Stack community. Do stay afterward. Well, we're going to do it's slightly different because we're going to do a key signing party afterwards. I think we'll probably do that in here. I go down to the diner. Do stay for
free coffee.
Free coffees afterwards. But otherwise,
Yeah.
we introduce Bo and he can.
Yeah. I'm Bo. I work for IDS for the cellular informatics team, which is part of Pipeline Solutions. And today we're going to talk a little bit about how we can secure a little bit of our part of the supply chain, basically by signing our tags and commits. Just want to make sure that people can hear us on Zoom. If somebody would just put a thumbs up. Okay, thank you very much. All right, right. Sorry about the AI swap. So I'm just what we're going to talk about is just a brief outline of the problem, and then spending most of our time about proving authorships of our code. How do we prove to others that our code is ours? And then a bit about protecting the build pipeline ourselves. A little just outlining how Docker images and PyPI packages can be signed as well. So the problem is really about pipeline, how we create software. We throw it into a Git repo. We then have a CI/CD build and testing. And then after that, we will have some sort of software artifact that we give out to our end users, or they just download it from GitHub. So it might not be quite like this. The problem is really around the integrity in a distributed environment. Because as we work, we don't work in the same room sometimes. We work different places. We distribute to people all over the internet. This is really about how we show people in the institute and outside that our code that we produce is actually built by ourselves, our team, in our pipelines, and also making sure that our software hasn't been tampered with. Now, this is when you look at this pipeline as well, you're probably thinking about what about all the packages, what about all the dependencies in our software. Well, this is not what I want to talk about today because that's a separate problem, and I think John Constable and the security team will actually happy to talk to projects or individuals about how they handle that. So we're just going to talk about how we can secure our little bit of the pipeline. So in order to prove authorship of a code, best practice is really about setting up our GitHub repo or GitLab repo. If that's compromised, then all bets are off. It's kind of like this is our starting point. For example, if we load up our public keys, which I'm going to talk about later, into GitHub repo or GitLab repo, and somebody can get access to it, then they can modify things, like they can put their own keys in and make it look as if things are going well when things are actually being compromised. At the same time, we should also look at best practices like protect our main branches and that GitLab pushes. Make sure that all our users have multi-factor authentication so that it's harder to, it's harder to basically break in. And that last point, code review approvals for entry to main branch. So that main branch becomes sacrosanct. Keep it safe. So SSH and GPG, we use SSH for access to remote hosts, and GPG is a sort of a general purpose encryption and signing tool. We can use those in GitHub with Git, and it's recognized in GitHub and GitLab. I'll show you some practical. I'm going to show you some practical stuff in a little bit, but basically the important thing is that we keep our keys safe. Basically, we can show others that basically things that we sign belong to us because nobody else can do that, and we can demonstrate that on GitHub and GitLab, which I'll show you. Also, every commit is a cryptographic checksum. So if we sign a commit, then we're essentially saying that we are actually endorsing that commit, if you like. We've actually tied our credentials to that, or we've basically signed that, meaning that if somebody modifies that, then the hash is no longer relevant.
No questions now at the end.
Sorry?
No questions now at the end.
Oh, yeah, sorry, yeah, just ask me as we go along.
Yourself and others, if you see a signed commit, do you see that the change introduced by this commit is the part that's signed, or do you see the resulting state of the repository as being signed? Like, do you validate the entire history of leading to that?
Okay, I'll get into that actually. I'll show you how we're going to do signed commits and signed tags. Actually, signed commits is a bit over the top in the sense that I'm not sure if every project is so important that every single commit has to be signed, but you can actually see it, who signed it. I'll show you in a little while. Basically, so we talk about this cryptographic checksum that Git has for every commit. And that includes, for example, when you have a tag, that when you sign that tag, that's basically a commit, and the repo at a certain time, if anybody modifies that, then that tag is no longer valid, and obviously there's no signature behind it. And it shows, I'll show you that trust signal on GitLab and GitHub we talk about. And then I think the things that's different between SSH and GPG is that SSH is much easier to use than GPG. And in fact, that's possibly what people are going to be using. GPG has the advantage that it has this idea of you can put it on a key server, meaning that you can actually see other people's keys, their public keys, that is, so that if I see, for example, Martin has signed a tag, then I can always go off to a key server if he's keys on the key server and actually see more information about him as well. So things like that. I can also have a revocation key, meaning that I can set a time limit for my keys where they'll expire. But more importantly, I can have a revocation certificate to be sent out that will actually revoke my keys validity. And also Web of Trust, which is this key signing party we'll talk about later. So that means that if, again, you can see that the key server, that if I sign Rob's key, then you can see that, he has a, when you look at his key, you can see that I've signed it, meaning that he has a, well, if you trust me, then you can trust that he's good as well. All right. So let's get into it. So let me quickly show you a little bit about what I'm talking about with these. So let's go to a, this is my, see, oh yeah, let's try SAMtools because I was looking at that earlier. Okay, so SAMtools, its HTS-lib is one of the core parts of SAMtools that many of you will have heard about. And Rob's good enough that he signs the tags whenever there's a release. So you'll see that we've got a tag 1.23.1. And if we click on that, we'll see that there is this little tick moniker. That's essentially, we're talking about the visibility. This is what GitHub does as well, shows in terms of it has a verified signature on that specific tag, that specific release. And here you can see information about the key and when it's verified. So when you do a tag, there's two types of tags. A simple tag, which is essentially just like a bookmark saying like this is version 1.1. It has no other information. Then you have an annotated tag where you have a little bit more information, including who tagged it, when it was tagged, and maybe some short description. And those, when you sign a tag, that's essentially what you're going to get. This is what you'll see here. So I don't think SAMtools has, you don't sign each commit, do you? Just, no, so no point. But some projects do, especially those projects where, like say, for example, the Linux kernel project, there would be quite a lot of the maintainers who sign their commits because, how does it say, making sure that you're getting the right stuff into the kernel is very important. So let's talk about, let's go back and look at the how we generate a key and just briefly show you how. First of all, let me ask you, how many people have used GPG for this kind of thing? Okay, so we got 2 people, right? I'm surprised. I thought most of you might have some background. So we can, most of you have certainly had the use of SSH, but we can show how both of them work. So if we generate, obviously that this could take longer than I thought, but we can generate a key. Let's go. And log back in. Let's get my back. So I didn't have much time to set up. That's it. There you go. Right, so I'll do it here. So then just follow the, you can have a signing key and encryption key, and the two, this is one of the things that GPD can do. So you can actually encrypt file, and basically, if you send that encrypted file and your public key to somebody, they can, assuming that you've encrypted it with their public key, then they can decrypt it. Sorry, they just need their own key. MyCity. Yeah. So there's encryption keys and there is signing keys, but the default is for both, and that's what RSA is. This is just about elliptic curve. I'm just taking the 2 years. Is not a bad one. Is this correct? Yes. And then put your name in, an email address. I've already done this on another computer, so you'll see that same. Now, comment is stuff you don't have to put that in, but you can put in, for example, if you're going to use this key just at the welcome, you might just put that in. Right. It's okay. And then I put Sanger 1. There goes, that's not good enough, but we'll do it anyway. Sanger. Okay. Right, so it's done that. So now so you can just see at the bottom here, yeah, that it's basically created this key. So if I do GPG list keys, I get basically the same thing. And what this shows us here, and by the way, you don't have to use the GPG command line. There's some very good tools also for Mac and for Windows if you prefer to use a GUI for this sort of thing. But essentially what this is telling you is that this is my key and this is the key ID. So when we talked about that fingerprint, which is something we're going to do later. So if I do GP fingerprint, I look what does the one for this is what you sent out, isn't it? Yeah. So dash fingerprint your email address. Yeah. So everything's fine.
I've lost your screen share.
Oh, I lost my screen. So instead of doing the fingerprint with my key name, key ID, sorry, let's use 15. Right. Fingerprint is actually this. Yeah. All this is saying that's not working. What this is saying. So let's keep that problem. Right. So created this. I don't think SSH will be a big mystery to people. It's just the same as creating any key, any SSH key, whether you want it for access or for signing. But then you also have to set up Git to use SSH or GPG, right? So as far as I can see, you can't do both. So you either use GPG or use SSH. And for SSH, it's a little bit more, you basically a bit more convoluted. You have to tell it that you're using that's not the one. Have to use a SSH format, and then you basically just point it to the key. So we'll do that in a little while. I'll show you how that's done. But with GPG, it's much easier. You basically just tell it that the binding key is the key ID. The key ID is what we saw earlier, which is essentially, let's clear this. List keys, and there's only one key, and it's this. If I point it at this hash, it knows that when it goes into your key store, that's the one it's supposed to be using. And because I've set a password, every time I ask it to do something, it'll ask me to put in my password if I want to do any signing. So there's that. Okay, now the next thing is GitHub and GitLab. So we have a way, so when, as you saw earlier on, when we were looking at, it was right there. When we were looking at the SAM tools here, the only reason why I got this tick box here and it gave us this information is because Rob's public key, not private key, public key is actually on GitHub. And I'll show you how to put that in right now. The private key, by the way, is sacrosanct. Don't ever lose it. I think we were just talking to Peter Clapham earlier about somebody who lost their private key. And usually that means you've lost control over anything you've signed before, or whatever, you have no control over that anymore. You have no revocations, nothing. So one good thing to do is to take your private key and actually save it to something like a key store or something like that. If you're using like BitKeeper or something like that, not BitKeeper, sort of a keeper online or something like that, you can put it into it's like a blob. You just put it there, just in case you ever lose it, lose the one on your machine. So let's go to GitHub. So here, account, and under settings is here. You've got this thing called SSH and GPG keys down here. And so with regards to, so what you're actually doing here is when you go a new GPG key, what you're doing here is you also keep it named like test. And then I need to put the key in here. I need the public key. Now the public key is stored on your machine in a binary format. So first of all, we need to extract it. And the way we do that is it's another incantation. So we do export ARMA. So that means it becomes ASCII. Then you can use the key ID here. And I get that. So basically, I would just copy and paste this to here. Test key. Now, see if it take it hopefully. I've got passkey. Done. So here we are. So now I've got two of them. Two keys, my own and this thing. So that's how you get it in. Same with the SSH. Basically, if you so the same thing. If you need to in the pub file, when you create an SSH key, there is let's have a look. You get two keys, right? And they're always in .ssh. So you'll see here, for example, I've got this one RSA. That's the private key, which should stay safe, and that's what's read only. And then there's the public key, automatically generated when I create SSH key. That one, if I cat that, I basically just put that into, and I'm basically putting that into the GitHub. RSA.com, like that. As you can see, it's like that. So it starts with SSH-RSA. We go back here, starts with SSH-RSA. So that's all I'm doing, paste it in here. So now the private key is up in GitHub, and therefore we can actually start writing stuff and signing it. Okay. So another thing I wanted to do is I did this export ARMA just a second ago. One of the things I can do as well is I can put my key into a key server. And this is sometimes quite useful, especially if we're doing this sort of key signing, is that if people are out, if you, for example, put a piece of work, like for example, you sign your tags or your commits there, and people out on the internet going, well, I'd like to validate that. I'd like to, for example, if I clone that repo, I want to be able to validate that this key is correct on my own computer. Now, one of the things you can do is, we're going to do that in a sec, but one of the things you can do is you can use Git to validate that the tag or the commit has actually been signed and I mean, it's correct signature. And if you actually have the key on your system, then you'll actually cross-check that and say, yes, it is a valid signature. So we have these key servers, there's a few around. And all they do is they just keep our keys in the public keys in the cloud, make sure it's just that. So if I do, say, BF15, UK, I search, you'll see this is my main key here. So this is useful, for example, for today, maybe when you're thinking, oh, who is Bo? This is my key here, key 77. So that's one of the ways you can sort of use your public key exported to be used in the key server. Right, so let's go back to here. So we've done this. Right, so now let's do some code signing, see how that looks. So I've got a little, let's see what it will be. Oh, my little sheet here. So I've created a little repo here. And it's basically, it's got very little in it, but it's got a README. So if I'm, for example, if I make say I make some changes to this README, okay, just a tiny change, and then I add the README, and then I commit it. But before I do that, I will sign it. This is the commit signing with a message, edit. Right. Okay, with that sign it.
Standard just signed off by. Oh, yes.
Let's keep my yes. So let's have a look and see if it did get signed or not. I have a feeling not. But let's look. So commits. Oh no. So this is the one I just did, and this is the one I did yesterday, and it worked. So yes, it's a great demo, isn't it? So let me go back to my notes
Might
again.
have needed a capital S looking at all.
I have a feeling it is the capital S. Yeah, yeah. It's the other way around for tag. It's just, you know.
Consistency,
For
yes.
reasons, right? So we'll make another little change. Okay. And then add, and then we'll put capital S in. Something magic ought to happen. So now this comes up. Okay, now let's see what I can remember. Okay. Wash. Right. And then back to the. So we do that. And now that's verified. Right, so I've got my key, public key in GitHub, and I've just signed it with my private key on my laptop and pushed it up. So now you can see that. So that means that there's a little bit more certainty around the code, like. So that means I've validated that at this very commit, and remember, being a commit is basically a hash of all your files that is in the repo at that point, and the status of them, and metadata, and the previous commit. A commit basically also points to the previous commit. So it basically says at that point, I've signed that and basically validated that is correct and present. So that's the important part. So if I now downloaded the source code, and I'll show you how that impacts. So if we go back to here, oh, that's not. I was looking for your repo again, SamTools, which I think. So if we go here, also see that. See. There should be a zip file there as well, if I'm not. So if we look at tags, we have 52 tags. Yeah. So here, for example, this is the repo. This zip file and tar file are essentially the things, the zipped up or tarred up state of the repo that that commit signed by Rob, which you can see here. Okay, so that's the useful thing. So that's kind of like what you'd like to see another, if you, for example, using something important from another piece of software that's important that you want to import. If people are going to this sort of habit of signing their releases, signing their tags, it's brings us a long way further forward in terms of the trust we have. Okay, so go back to our little, yeah. So, oh yeah, so yeah, we've seen what you've seen what the tags look like. It's the same sort of thing, basically. It's an annotated tag and it does just what you saw. In the interest of time. All right, just a little bit extra thought I'd say is protect or build pipelines, because we've got good software that's protected and signed by us and pushed into our repos. If our build pipelines are compromised, again, something could happen. For example, if they pull it, do things where, for example, passwords are, they're pulling in sort of stuff that we don't know about, and that's where packages, third-party packages and stuff comes in, which we can't really do much more than actually run dependency scanning tools on. One thing that's becoming a thing now is software bill of materials, and this is more to do with, especially with compliance. So if you've got a piece of software that's used in environments where some compliance may be needed, then there's software bill of materials, which essentially shows, gives a description of all the, it's a little bit like a configuration.txt file that you use in Python, but it's got a lot more information in it. And it just helps to ascertain about what exactly is going on in there. And the other thing that you'll find is, if I can get out of this, one thing that you'll see is in some repos now, you've always got this security tab. What people are also saying is make a security.md file, which defines your, it's basically a way of defining your security policy, also in terms of how you handle security problems, like for example, turnaround times, you can put it in there, who to contact, etc. Just one. Then I thought I'd just say, open your eyes to the fact that you can sign Docker images. I'm not going to demo this here because it's actually very convoluted, but essentially there are ways in your build pipelines to create Docker images and have them signed without actually having anybody sign it. So for example, when we're signing the tags and the commits, we actually had to do that ourselves because there's a password involved. But you can use what is called OIDC, which is OpenID something or other. Yeah. To basically use what do you call it? You can sign stuff. You can sign things, but you don't need to actually have a signature to have it signed. It's done through what's it? Auth 2 is it's very similar sort of protocol to that. And it's using something called cosign, which means you may start seeing a lot of. So cosign is the tool to sign Docker images, essentially. And you build a container image and then it's signed afterwards. PyPI package is a little bit different. There's a relatively recent standard by Python standards, which has come into force at the end of 2024, I think. It's called PEP 740, and it's basically about digital attestations, which are basically these, it's called the supply chain levels of software artifacts, which is essentially a JSON file, which defines what's in your package, and essentially that's signed. And then that goes as part of your PyPI package, but it's an official Python standard And there are ways of validating using the PyPy toolchain to see whether or not it's been signed or not. And again, a little bit of things like have pin versions, just like with Docker containers, like use buildx for deterministic builds. You know, everything should be deterministic if possible, because otherwise, you know, the things that we can control depend on other things as well. So if we keep building it differently every time, we have no idea if there's a bug or a security problem. It may not be, it may be because of some change that we didn't anticipate. There's not many questions going on here, but look at the other swap here. Any questions? I haven't seen if there's anybody from the Zoom who's got any questions, but any questions by anyone? Yes.
Is the point of the passphrase that if someone got access to your device, they wouldn't be able to commit with your,
That's partly it, yes.
like a password for a password?
Or like you leave your laptop and go off for a cup of coffee and your teammates sitting there trying to get it.
Okay.
You showed us where the private key was stored for SSH. Where is it stored for GPG?
It is stored in .gpg itself, so we can have a look at the leaf. Yeah, it's GNU-PG, so it's in here. But a lot of this stuff is in KBX files. They're all binary. So this is part of it makes it much smaller, but it does mean that, for example, when we export the key, we have to make this -- armor, so it creates a nice ASCII.
Which files would you back up? Because you were saying make sure you don't lose your private key.
Yeah, I would just take the let's see, I think it's the trusted DB. That's other keys. It's just this one here, private keys. I would actually just take the whole thing and keep it safe.
You can export them as well.
Yes.
You can export them in the same way as you exported the public one, just don't email it to anybody.
To whom it may concern. This is my private key. Many thanks.
Yes.
I think it does export it presumably. Actually, I'm not sure what when it exports it, is it protected by your passphrase still? I don't think it is actually.
Yeah. So you've got to be quite careful. Yeah. But yeah. So what some people do is they take a copy of this directory and just put it on a USB stick and put it in a very safe place. A little bit in the same way that if you have a, let's say you've got some third party, authentication app, they usually give you those keys, those key codes or whatever, in case you lose your device. And same sort of thing, you take that and put it somewhere safe. So it's really about managing security like that. Anybody else?
I was thinking about the merge commit. It's verified by the people who do the merge. Oh,
Okay, so if you do it, if you're signing commits, if somebody does a merge, it's essentially, they're creating another commit, right? And it's up to them whether they want to sign or not. But usually the way that I would work is don't bother with signing your commits unless you're really, because it'll get old very quickly. And some people will do it, some people won't. And we have some automated tools we use like Gitflow. I've used them one project, for example. We have Gitflow, so even creating the tag and everything so we move everything to the main branch. We create a tag, and it's basically pushed up to the repo. At that point, we have an unsigned tag on the main repo, say 1.1.1. So what I would do then is I would actually delete that tag and create my own same version, and then I would sign it and then I'd push it up. At that point, there would be a signed tag. That's all we would do. But the reason I showed you the Docker and the PyPy stuff is that that's something we are kind of looking at, because I think that especially as people consume, they're not just downloading a binary or whatever. They're usually cloning your directory or using PyPy or Docker to consume your software. So at least cloning, git clone, I don't think there's any way to test or check to see whether or not the tags are signed. There's ways of Git to validate that the tag or the commit has been sign, but there's no way to validate a Git clone. So we just try to do what, we try to do what we can, right? Can't do everything. So we try, but I think a Docker image is useful, and Docker has a lot of, Docker themselves has a lot of discussion about these secure Docker images that they're pushing now. And so if you build your software on top of these secure images and sign them in turn, it sort of gives a lot of trustworthiness, I think. Yeah. All right. Wow, everybody's very quiet. That's excellent. How many of you? Yeah, of
Another
course.
question.
Yeah, I was
So I created a key as part of doing this,
Yay.
and at no point did I have to prove that that's my email address or anything. I could upload it. I uploaded it to key server. Anyone could do that. Other people could do it.
Yes,
Not
very
ju-
much.
Is that just where the web of trust comes in?
It helps.
Yeah.
It helps. So one of the things I could add by that is that with GitHub and GitLab, they handle it's very similar sort of way they work. But basically, when you push up your public key, they will just validate that that's the same same email address that you're using for your account. But you've obviously got to be logged in to do that. With GitLab, they actually validate your email address, even though you've signed up with it. You just say which email address you want to use. Maybe I can show you a few seconds to show the GitLab version. Yes. So here's so if I go to here, oops. Settings, preferences, isn't it? GPG keys. Right, you see this verified here. What happened there was it asked me to when I wanted this verified. I clicked on that, and it basically sent me an email and with a string, and I gave that string back to GitLab, and then it's verified. But the joke about this is because I'm using a subkey, this is another facet of GPG. So because I've used GPG for some years, and when I set up my GPG key, I didn't work at Sanger. So what I did is I have on my laptop at home, I have my crown jewels, my actual keys, and I created a subkey which has only a year's validation, and that's what I use here at Sanger. So I've uploaded my subkey to GitLab, and it doesn't validate it. So when I have a if I actually sign a tag, it actually says it's unverified. That's just a bug. I have a example of this. If we look at tags, pipeline, that's something else. So if we look at the tag. Oh yes, here, unverified. So this is a known bug in GitLab, but I don't think if you just used if you didn't subkey like I have, you'll be fine. All right, yeah. So how many people might be interested in using this in their projects?
Maybe when we do a release.
Yeah.
I think it's good. I mean, Rob, you're probably the one with most experience here. How has it affected? You use SAM tools, which is your hardware, which is a pretty important project. How does it work for you?
And what we have is basically making a SAM tools HTTP release is a bit complicated anyway. So there's a script which does it, or but there's a repository called CMaint in GitHub which has all the release stuff on. And you run a couple of programs. One is called tag release. That basically goes and makes the tag. Actually, it's sort of using Git flow, so it also so there's one called make release, which basically puts all your changes on the master branch, and then tag release tags that, and then merges back onto the develop branch with your updates and things and everything else you put in for the release notes. Yeah, so it's part of that, and it also does it for 3 repositories. So it's important to remember to type your passphrase in first. So it's in the keys and the local keychain, and then it just goes black, and everything gets signed nicely, and yeah, it works really easily. Yeah.
But do people actually ask about it? I mean, is there any sort of direct, just because you've got it there, have you actually got any feedback that people actually appreciate it being there or not?
No.
Okay.
I expect
So-
most people probably don't notice, but yeah.
Yeah. Okay. But otherwise, you would just get this unverified, right? Which is what, you know, what people don't want. But yeah, so
I mean, it's more difficult for somebody to replace, you know.
Yeah.
There have been cases where people's tags
don't
have
see
been
anything.
replaced.
Yeah.
Although if you can do that, you've probably got access to the repository anyway, so you might be able to replace it with your own signature. You'll notice it's changed.
it will be changed, yeah. So, but anyway, there's probably a lot more of this coming. Yeah, go on.
This one goes for free on GitHub, probably on GitLab as well. If you got your GPG key registered, whenever you merge a pull request, so GitHub will create a commit for that merge and uses your credentials and it will sign it with your GPG key. So it's a way of getting some.
I can't sign anything
No,
because it only has your public key.
yes.
Yeah.
Yeah. Public key is just for validation purposes.
Some taken.
Yeah. The private key should stay on your machine and shouldn't be anywhere else.
It's very.
It's just backed up. Yeah. So,
No, it says. Okay.
Yeah.
It says verified, but when I click on it,
Hmm.
this commit was created on GitHub.com using GitHub's verified signature. So
verifying the
their
signature.
own signature, not mine. Okay, sorry.
So, but anyway, a lot more of this stuff is coming, I think. It's all about supply. That's where we got that silly Churchill picture at the front. It's really about where we fit in the supply chain, especially if we're producing bioinformatics tools, which are used in other bioinformatics tools sooner or later, especially when they're important or critical to research or whatever, that people want to make sure that it's from the right place. And I think same with Docker images and stuff like that. If we have I think with SAMtools, there's lots of Docker images out there, but if you did your official one and you signed that, that would probably be the one that people would want because it means that there's a bit more gravitas because the whole team are behind it, that sort of thing. All right, let's cap it there. Yeah, thanks very much. The stuff. Hope you learned something today anyway. And thank you very much, those online.